So in this question, we're going to go and try and find the motor constants, which are Kb and Kt, the back EMF constant and the torque constant respectively. And we're going to need to utilize this diagram that we're given, which relates together the torque and the speed out of the motor. So to start off with, I'm going to try and look at what's happening in the circuit here. So for this, I need the current in the circuit, which I'm going to call IA. And I also need to record how much voltage is dropped across the motor, and I'm going to call that VB, where the B stands for back EMF. So the equation I need to satisfy is that the sum of the voltages in that circuit is equal to 0. This is the mesh analysis. So into the circuit I have EA, so it's positive, and I'm going to drop voltage across this resistor, so I'll make it negative. And it's going to be equal to the resistance times the current. And then I'm also going to drop across here, which I'll call VB, and that's equal to 0. So at this point I need to substitute in my motor constant equations, and I have two of them. So the first one is that Tm is equal to KTIA. So if I want to substitute this back into the other equation, I'm going to need to rearrange it for IA. So that then becomes Tm on KT. So I'll put that in a moment. The second equation for my motor constants is that VB is equal to KB times the speed out of the motor, theta m dot. So that's already in a form that can be substituted straight in. So let's go ahead and do that. So EA is going to stay there, R is going to stay there, IA is getting subbed out, VB is also getting subbed out. Okay, so to be able to solve for KT and KB, I'm going to need to use this diagram up here. And we can see that it's in terms of Tm, which our equation was in, but also omega m. And at the moment we don't have that in the equation. But theta dot m is actually equal to omega m. It's the derivative of theta with respect to time. So what that means is I can quickly chuck this in, and we're going to be good to go in terms of starting to substitute stuff. Oh, sorry, I didn't even replace it after all that. Omega m. Alright, so I've just copied this down so we can look at it at the same time as the equation that we've got. So let's start by looking at this point here, which coincidentally is actually the stall point. It's stalled because speed is equal to 0. So at this point, at stall, omega m is equal to 0, obviously, and Tm is equal to 25. So we should be able to substitute that in up here. EA, of course, we're given as well, it's 24. So 24 minus the resistance, now we're actually given that up here as 2 ohms. Tm, we're substituting in as 25. KT is one of the values we're trying to find out, so we'll leave it there. KB we don't know. And omega m we're substituting in as 0, so this all goes away. So going ahead and trying to solve this, we're going to get that 24 is equal to 50 on KT, and that means that we can solve for KT, and it becomes 2.08, and the units for KT, the base ones, are Newton meters per amp. So that's the first answer that we were looking for. So now we can kind of repeat this process, except we're going to use the other point that we can identify off the diagram, which is this one down here, the no load one. So at this point, we can see that we have no torque is equal to 0, but we have a speed of 50 rads per second. So going through and applying it with this equation again. So EA is still 24 because that's what the case is that we're given. The resistance is 2. Tm is going to be 0. KT we have, but it's not really going to matter. It's going to cancel out from being 0 on the top line. KB is what we're trying to determine, gets multiplied by 50 is equal to 0. So that's that equation filled out. And it just becomes a case of needing to solve again. And this one comes out to be 0.48. And the units for the back EMF constant in base, which is what we've been using, is volt seconds per radian. So that's the other answer. So that's all there is for this question, since all we were asked to determine is the motor constants. So see you in another video.